One of the more useful tools for testing is code coverage analysis. Code coverage analysis tells me which lines of code are executed during my tests and how well they're executed. Now, code coverage analysis is not a panacea for all problems. It has its limitations. It has some problems that can occur if we rely on it as our only way of verifying that we have good tests. But it is a very, very useful tool. Now, basic code coverage tends to start with the concept of essentially statement coverage. Statement coverage says, did I execute a given line of code? The next step beyond statement coverage is something called branch coverage. Branch coverage essentially looks at a piece of source code and says, for my branches, which branches did I take and which ones did I not take? So in this video tutorial, what I'm going to do is show you how to use the tools built into IntelliJ to actually record branch coverage and how to generate a report from that information. So let's get started. Right now on the screen, what you're seeing is a test case here for a program or a class essentially called a number summer. This class, really what it does is it's an implementation of code that will sum between a start and an ending number. It doesn't really have a whole lot of complexity to it. And what we want to do is write code that is going to verify the operation of this. That's going to be our test cases. Now in this particular example, I'm going to use a tool called TestNG to do that, just because it gives us a nice data provider that makes it a little bit easier to do this type of testing. So what we can see from our test standpoint here is I have something called a data provider, which is going to say I want to pass in a starting value of 5, an ending value of -5, and I'm expecting 0. If we think about it, the start of 5 and the end of -5, the sum of all numbers between will be summed. If our start is after our end, we're going to return 0, which is this case right here. Now what I'd like to do is actually pass this test in and see what parts of the code actually get covered. So at IntelliJ, I can do this pretty easily. I can click up here on the test case, and what I'm going to do is run with coverage. As I go and run with coverage, the code will actually rebuild, and when it's done rebuilding, we will see over here that I have one class being tested, one method being tested, 45% of the lines have been covered. If I click on it, we can see on the screen the green line here and the green lines here indicate that those lines were covered. These lines were not covered. Now, I can add more test cases to this, and I can go farther, and we'll do that here in just a moment. What I'd like to do is maybe get a little bit of an improvement into my code coverage, basically by setting up so that I get more depth. This line coverage basically means, did this line get executed or not? Not, how did the potential branches get taken? How did the different decisions essentially occur inside of here? So what I'd like to do is actually go in and edit my configuration to get a little bit more detail. In IntelliJ, if I go in here to the code coverage, I can change into what's called a tracing mode. Tracing mode means that I'm going to get a little bit more information, not just say, did this line of code execute, but exactly how did we get there? What path did we take to get into that line of code? Once I have that path captured, then I'm able to actually figure out how did all the decisions flow together that caused me to get where I'm going to. So I want to turn that on to tracing, and I'm going to actually go back now and rerun my test cases. So if I run the tests, again with coverage, what we're going to see over here is that my branch numbers are now being shown. So branches are going to show which of the branches in the code were taken. So here I can kind of select here and say that in this particular case here, for this branch, line 12 here, I hit it once. I only had one test case. And the one time I hit it, I took the true path, which led me to right here. I never went into here and took the false path, which would lead me to here or here. Now that's kind of obvious right now because I've got the pink showing here. Now, I can go a little bit farther here if I have a test case, for example, that says start equals end. So let's come up with a start equals end scenario. And I have one pre-written here. I can take this and enable this test to run here. So we're going to have the start equal to the end. So we should take the path 9, 12, 14, 15. If I go ahead and save this code now, I can run these sets of tests again. And momentarily, we'll see now that my branch coverage is 1 out of 2. I can click on it here and see. Okay, so this particular branch here, if I click over here, I see that I hit it twice. One time true, one time false. I took both branches through this piece of code. Then I can go down here and I can see this particular branch, one time true, one time false. Okay, so we've got that. Now, what I can also say is I've never gotten down into this particular code here. Because you notice it's pink as well. What I want to do is add another test case in. So I'm going to add the test case that I have here, going from -1 to 1. Now, why -1 to 1? Because. So, -1 to 1. I'm going to step from -1 going to 1. I should expect to have a value of 0. And I can run this as well. Oops, and I didn't want to just run the tests. What I actually want to do is run them with coverage. And we will see now that 3 out of 3 sets of branches have been taken. This top branch here, 3 times. 1 time was true, 2 times were false. This next branch, I hit it 2 times. 1 time was true, 1 time was false. Then we've got this here, hit it 4 times. 3 times were true, 1 time was false. So 3 times I went through this loop inside. 1 time I didn't. So I can get more information than just code coverage. I can see how many times I took one decision versus another decision. And if I have complex decisions in my code, I can see how much each one of those complex decisions made a difference. So for example, I could take this line of code here and put another decision into it. Oops. And actually what I want to do is have start less than end. If you think about it, this decision here is always going to be true if we get down to this else condition. So this is actually a superfluous decision to have in the code. Let's see what happens now to my branch coverage now that I have added this into the code. So I'm going to add it in. I'm going to run the same set of tests with coverage again. And we can see that I have got, again, 100% statement coverage. All of the statements are green over here. But I've got this yellow here for this set of conditionals. We can see that I never made this second conditional here, the second clause in the overall predicate, go false. Because of that, that's a sign that I might need to add more test cases. Now, in this particular scenario, there's nothing I can do because this is always going to be true based on some logic I have up here. If I saw this in testing and could guarantee that that was the case, which I can do in this particular case by looking at the code, what that means is that this decision, this extra piece of logic here, should be refactored out of my code. So all right, at this point, I've demonstrated how to use IntelliJ to look at code coverage. And I've also demonstrated how you can make IntelliJ do branch coverage in addition to just simple statement coverage. That's going to bring this video to a conclusion.